Hi everyone, this lesson is going to be on the three forms of a quadratic equation. So let's get started. Here's a graph, a short graph of a parabola. The only thing I would add were these. And so let's label the different parts here. Okay, we know that this part is a minimum. This is the vertex, and the coordinates of this vertex are going to be hk. So in other words, this coordinate's going to be h, and that one is going to be k. All right. The y-intercept is going to be where the graph crosses the y-axis, and that's going to be at 0, c. So this on the y-axis is going to be c. That's the point 0, c. The roots, and I'll do those in red, are where the graph crosses the x-axis. And we've learned before that sometimes the graph doesn't cross the x-axis. Sometimes it either comes down and bumps against it like this, a double root, or it doesn't cross it at all, which means it has imaginary roots, non-real. But this one has real roots, and so this is going to be R1, and this is going to be R2, and so those are the roots. So that's how you would actually label this graph. One other thing that's not on here is the axis of symmetry. The axis of symmetry would go straight through here and would be the equation x equals h. So you can write the equation of a parabola, a quadratic equation, in three forms. All right, so the first one I want to start with is factored form. So in other words, f of x is equal to x minus root 1 x minus root 2, if we use what we used, the picture on the previous screen. Okay, vertex form is going to look like this. F of x is equal to a x minus h quantity squared plus k. And then standard form of an equation looks like this. Ax squared plus bx plus bx plus c. All right, and you'll notice that on that previous screen we used roots to write factored form, we used the vertex to write vertex form, and we used, this one included the y-intercept, which was c, and a. Notice that standard and vertex both have a, it's the same a. And that tells me whether it is a maximum or a minimum. Also tells me if it's a stretch or a shrink. Okay, the following are three forms of the same quadratic equation. The first one is written in factored form. This is factored, right? This is standard. And this is vertex form. Okay, so find the following and identify the form of the equation that gives that information. All right, so the y-intercept, the easiest thing to find the y-intercept, if you'll remember, is that I'm going to let x be 0, and that's c. And so the y-intercept is going to be the point 0, 8, and I would use this standard form to find that. Okay, the vertex, if I used the standard form for the vertex, right, I would do negative b over 2a, which would be negative 6 over 2, which is negative 3. All right, so if I didn't want to figure it, I could actually look to the vertex form of the equation and see that this is h and this is k, and that the vertex form of the equation had a minus in it. Right, so this is going to be, the vertex will be at negative 3, negative 1, and I would use the vertex form to find it. Okay, roots, another word for roots are x-intercepts, solutions, zeros, all those mean the same thing, and I'm going to use factored form. And if you'll remember, factored form comes from standard form. In fact, both of them do. but because you can complete the square to find the vertex form. So the roots are going to be at -2 and -4. So on this particular one, it asks us to write the equation in standard form. Well, currently it is in vertex form. Okay, so what we want to do then is just write it so that it's in standard form, and standard form is ax squared plus bx plus c. So I really just need to multiply everything out. So we'll do this in bits. I'm going to leave the -2 and the +4, and I'm going to multiply x plus 2 quantity squared, perfect square. So I have x squared, the middle term is 2 times x doubled, and then 2 squared is 4. Now I'm going to multiply all the way through by -2. I forgot the sign on that. Okay, plus 4. So this is going to be -2x squared minus 8x minus 4. And that is the standard form of that equation. Yep, that's it. Okay, now given the following graph, we're going to write the 3 equations that represent this graph. All right, so we've been given roots. Our roots are at -1, 0, and 3, 0. There is a vertex. The vertex is at 1, -4. And there is a y-intercept. And the y-intercept is at 0, -3. All right, so if you're given the roots, both roots, the easiest thing to do is to use the roots to write the standard form of an equation. Now you have to remember, though, that there's a, and a is the stretch or shrink. So I'm going to do over here, factored form is going to be a x plus 1, right? That's one of my roots, and x minus 3. Those are my roots. Now, one easy way to find out what a is, if you'll recall, is to start at the vertex, right here, start at this vertex, and then go over 1 and count how far up it goes, right? So if I go over 1 and up 1, then a is going to be 1, and I'm good. Another way to do that is to pick another point on the graph and substitute for x and y and solve for a. Okay? So on this particular one, it should be, a should be 1. But let's see if that's correct. So let's pick a point. Let's pick 0, -3. Okay? So we'll pick 0, -3. We're not going to pick a root, because if we pick a root, it's going to equal 0. So I'm going to say -3 is equal to a, and then I have 0 plus 1 is 1, and 0 minus 3, which is -3. And so I have -3a equals -3. So guess what? A is 1, just like we thought. All right, so factored form is just going to be x plus 1, x minus 3. To get to standard form, right, because a is 1, standard form, I'm just going to multiply that out. So that's going to be x squared minus 3x plus 1 is minus 2x, and then 1 times -3 is -3. Done. Now, let's do a quick check here. Where is the y-intercept? Haha, it's at -3. So we're good. We got that. Now, vertex form is going to be a times x minus h. So the vertex is at 1. So x minus 1 quantity squared minus 4. And those are the 3 that we're going to do. So we're going to work with this some more in class. But I wanted you to have these notes written on here so that you will be able to tell the difference between the 3 forms of the equation. They're just 3 different ways to express the same graph. All right? So I'll see you in class.